Hey guys, hi. I'm going to discuss the lead code question number 85, that is maximum rectangle. So this is hard question. So I have seen the solution and I'm going to explain the solution so that it can be easily done by anyone. So I have created a GitHub link for this and I have committed my code in the GitHub. So let's see the solution in GitHub account. In my GitHub account, see PCAMSoft Pro Leetcode. So this is the solution, and yeah. So let's see what is actually happening. The thing is, as you can see over here in this matrix, so we will traverse this matrix row by row, and while going through each row we will see the height, uh, see the height of see the height of that that matrix. So uh, at column 0 the height is 4, right? For this row, let's see, for this row, uh, at column 0 the height is at column 0 the height is 1, at column 1 the height is 0. In the similar way, let's see the second row. So in the second row, if the if we keep, as we go, as we traverse from row to another row, we will keep on incrementing the height. If the previous is 1, if this is 1, the current is 1, then we will simply increase the height of this guy. Then we will move ahead as it is 0, so the height will be 0. At this place again the height will be 2, this place height will be 1, this place height will be 1. Now when we will be traversing through row third, so at column 0 the height will be 3. At In the similar way, like, you can add it up. In the second column, the height will be 1, in the third it will be 3 again, and when we will be traversing through the last row, so if it is 1, then we will take the height plus. If it is 0, then we will store the height as 0 only. We will not consider this one or any other one at the top. So that is the height thing, and that height is getting calculated over here in this for loop. You can see that. So we will be traversing row wise, like each row we will be traversing through, and within each row we will be traversing through the width of that row. And if the row is 1, then the height will be incremented. If it is 0, then the height will be initialized to 0 irrespective of its previous value. And now after calculating this guy, after calculating the height, see this operation is happening row wise. So first of all we are calculating the height, then we are calling our recursive operation largest rectangle here. So now let's see what's largest rectangle is actually doing. Yeah, in the largest rectangle, so these are just the base cases. If the start is greater than and it is it should we should be returning 0, right? Because start can never be greater than end. If it is start is equal to end, then the same height, whatever the value of height at that location is, we are going to return that. So these two are the base cases. Actually, I have to look for this guy. I'm not sure whether this is possible or not. I think, like, even if we are going to remove line 39, our code should work fine. But I have to debug for that. So let's move ahead for now. So the min index So again, this guy mean index, we are initializing it to start, whatever the value of start will be. And again, so this is very important thing, guys, we have to notice over here. Yeah, so within this operation is happening row wise, right? So now this operation is happening throughout the width in that row from start to end. You can see it here, right? Yeah. So actually we are maintaining three stuffs over here: increasing, decreasing, and the min index. See, if the element are in increasing order, then this guy will be getting changed. If it is in decreasing order, then this guy will be getting changed. But if it is neither increasing nor decreasing, then we just have to look at the minimum guy, minimum this guy, like within the height of histogram, whichever has the minimum height, that height is the min index. Okay, let's move ahead. I'm going to explain these things in the notepad also. So for now, just uh, look uh, just go through the code, and after that I will explain it in the notepad. And so we will after this operation, we will know either the height sequence in the height array is increasing or decreasing, or like it is uneven, like sometime it increases, sometime it decreases. At that time we will consider this guy. Now see, if it is decreasing, then what is going to happen? See, this is very clever operation. This is very extremely clever operation. These guys are very clever operations. You can see over here, line number 54 and 59. See, the height of that matrix will be as it is decreasing, right? So uh, the biggest one, after that the smaller one, after that the smaller one, after that the smaller one. So n minus I with that height. Okay, yeah. So while considering the decreasing case, so the current height will be the minimum height. So just we have to multiply it with the distance between start and end, right? And uh, we have to keep on repeating this operation until we get the minimum value. So this math.max res the previous value and then the current value, whichever will be the minimum, is getting stored in result. Okay, let's move ahead. In the descending also the same thing is happening. And if the height are in disoriented way, it is neither increasing nor decreasing, so we can consider it is in disoriented way. So yeah, in that condition what we can do, see, we have already calculated the mean index, right? So this range, start and end, uh, this guy is a similar operation like the quick sort. So uh, not exactly quick sort, I guess, some other operation, but we are considering the start and end. It is not like the start zero. Suppose there are 8 elements, then it is not like 0 to 7. It is sometime it is 0 to 4, 0 to 5, like that, right? You get the idea. Okay, so height and then mean index. So see, the thing is, we while calculating the area, the maximum area will lie either in the left side or in the right side of the minimum index. So minimum index is not going to get included. So after calculating mean index over here, So we are doing either +1, see over here, +1 or -1. That means we are not including min index. So this is a recursive operation. It will again iterate over this guy and this guy. So we already know it. So I'm not going to discuss any further, and I'm not going to dig deeper for this one. And beside these two operations, we also have to consider the min index height into the whole length. So min index, the left side and the right side, see, we also have to consider that area also, right? If that is the greatest one, then we are going to consider that as our result. Okay, so uh, now let's, I'm stopping sharing for now. Okay, yeah, so we can focus in this guy. So what we have discussed, I'm going to write it down over here. Okay, so this is this guy, I get this number from the histogram question. I'm just going to tell the histogram for 1 second. Okay, 84th question of Leetcode is the histogram question. So these two questions, maximum, rectangle, and histogram, these are kind of similar, right? Okay, now let's consider. So the height are like this. We already have seen the height can be 2, then 1, then 5, 5, then 6, 2 and 3, right? So the maximum area for this guy, how we can calculate the maximum area over here. So how many in the base, how many squares are there? 1, 2, 3, 4, 5, 6. That is the number of elements, right? 2, 1, 5, 6, 2, 3. Sorry, now it is visible. So 2, 1, 5, 6, 2, 3. So the maximum area will be, this guy is 5, this guy is 6, 2, 1, 5, 6, 2 and 3. So this area will be the maximum area, right? 5 of this height, 5 of this height. So 5 into 2 is equal to 10. Remaining all other areas will not be as big as this guy, right? So let's take the base of height 1. So because this is the minimum height, right? 1 is the minimum height for this complete array. So 1 into 6, which is 6, which is not as bigger as 10, right? So this is the biggest one. So based upon our previous logic, so we will create a height matrix, height array actually, and we will keep our element, all the elements over here. Got it, right? Yeah. Now we will iterate. Now this is the largest rectangle method, and now here we will be finding increasing, decreasing, and min index, right? Increasing, decreasing, and min index. Now increasing, decreasing, and min index. So this guy, initialize this to 0. All this guy is a 0 right now. So let's iterate for I is equal to 0 to the length of this element to 5. Okay. So while going from 2 to 1, so it is increasing, sorry, decreasing, minus minus. So decrement will become minus 1 from 1 to 5. It is increasing, increment will become 1 from 5 to 6. Increment become 2, 6 to 2, decrement become 2, minus 2 actually, 2 to 3, increment will become 3. Got it right? So in this way we can see our height array is neither increasing nor decreasing. So now what the third condition is going to happen, as we already have seen in our code, the first two either increasing or decreasing. So it is neither increasing neither decreasing. So max large of this guy, large of area 1, large of area 2, or height I into number of elements, that is 6. Now these three guys will be getting called recursively. So now you have got the idea of this thing, how this thing is happening, right? Minimum plus 1. And after all the three operations, we are simply going to return the result over here. And we are also going to see through the stack way. And so see this increment and decrement main as I've shown over here. So see if see, so this was the matrix actually uh, from the maximum rectangle. So this will be the height matrix actually. So we are considering this guy. We are going to consider this guy 31322. So in this condition 31322, let's see if it is if the elements are increasing or decreasing. So 31132, right? So 31132. So while going from 3 to 1, it is decreasing minus minus 1 to 1, neither decreasing nor increasing. So from this mean index is going to get calculated, which is going to be 1 only. Again 1, 2, 3, increasing. Sorry guys, not this number. The other number is there. 31322. 31322. Okay. No proper area. 31322. So from 3 to 1, it is minus minus 1 to 3, incrementing plus plus 3 to 2, decrementing minus minus 2 to 2. It is neither decrementing nor incrementing. Mean index is equal to 1, or in this condition 2. Okay. So just I just wanted to show you when incrementing or decrementing are 0, when incrementing and decrementing are exactly 0, then that increasing or decreasing operation is going to get performed. If the elements are increasing or decreasing order, then this condition will never be going to happen. So this is very clever idea. Okay, now let's check on our stack solution, stack-based solution. So this solution is stack-based solution. So So in the stack-based solution is also the similar solution as we have seen earlier. But the thing here is it is using stack, so which is making the operation more efficient. So the see if the uh, height array is increasing, then height array is increasing, then we will simply keep on pushing the elements in the height array in the stack. Okay, but if it is decreasing, then we will go in the else condition. Okay, so now let's see in the notepad. Actually, this thing will be required. Is there any way I can make it bigger? Okay, let's stop share from here and start sharing this guy. Okay, now can I share? Yeah. Yeah, I guess we can adjust in this way. Yeah. Okay, now we have the element side by side. This thing I was actually wanting. So now we can do this guy. While as start now, what are our elements? 9, 6. Okay, 1 second. So as you can see, the else condition. Now let's consider this area. That is 5, 6, 2, 3. Okay, now uh, while I is equal to 0 to width, that is 0 to 5, right? Now for 2, so S push, so S will contain 2, right? Now when 1 will be coming, so 1 is smaller number, so it will go in the else part. So top will become 2, right? Top, this guy will be coming, this guy will be coming into the top, and I is equal to 1. So area will be top 2 into S is empty, so I only, right? I is 1, so 2. Area is 2 as of now. Now again another element 5 will be coming, so S dot push, so S will contain 5, right? When 6 will be coming, as the element is increasing, so S will now contain 5 and 6. Now 2 has came, right? So now else condition will get executed. Else condition top will be, see, I is 4 right now. Top will be 6, right? 6 into area is equal to 6 into, as the S is not empty, then I minus S dot peak. So 6 has already been removed. Now if we do peak, then we will get 5. 5, 6. Actually, these are not the elements over here. These are actually 2 and 3. So 3 is already peaked, then 2. I 4 minus 2 minus 1, which will become 6 into 1 is equal to 6. Now the while loop again, because S has element S, so only 3 has gone. S has one more element, that is 2. That's why will S part will again get Y part will again get run. Now top will be 5, 5 into I is 4. I is what? Shit, I wasted too much time just for this guy. See, uh, I was considering this guy, but these are the elements. Actually, this guy are getting stored in the S. So S contains 2 and 3. 3 already been processed. So for 2 we are processing, right? So top is equal to 5 now, and I, because S is empty, so into 2 is equal to 10. So this will be the area. That's it. So this was the whole solution, guys. So also keep on pushing the element in the else part. So I didn't notice it earlier. I'm noticing it right now. So I can stop sharing my screen right now. So that's it, guys. I'm going to start the recording right now. Do we need to see anything more? These two are already discussed for now, right? Okay, this guy can leave the meeting. Okay.